Hello everyone, welcome back to Structure Expert. Today we continue to analyze and design core wall OP in CSI ETABS V20.3.0. Now let's start. In this tutorial we will show you how to check ETABS wall group, how to check her analysis result by using peer visual reaction at the bottom of the wall, and what is different, and how to design the core wall. Now let's start. Click on select object type, click on walls, select close, right click, so select object only. Okay, now we want to display only core wall, so now I want to turn all other object. Okay, horizontal, diaphragm. Now let's check. Okay, by clicking one panel of the core wall. Now let's click on one panel. You can click this panel or this panel side. Okay, right click and check about the group. You see here there are two group. Yes, two group. Click on it, group all and group wall stack 2. Okay, again click on this panel and check on group wall stack 2. So all wall in this core wall, now I let's call it right core wall, and this one is left core wall. The right core wall is in group wall stack 2. Okay, wall stack 2. Now let's check the wall in the core wall at the left. The group is wall stack 1. Okay, now let's check in the group. Click on select group. You see there are two group automatically created by the software ETABS, a group wall stack 1 and group wall stack 2. So all the wall panel in the right hand is the group wall stack 1, and all the panel in group left hand is the wall panel stack 2. So the software automatically group and assign it to different group for this panel. Okay, see here there are two main core core wall at the right side and at the left side. So now let's display about the result. You can check by display supports or spring reaction. Now let's start and display this option first. You can check on the load case. Load case is individual load, deload, light load, wind load, and so load combination. Now you can click check load combination for gravity load or for include lateral load. Now let's click on display. You can click all, both for the moment and for the horizontal force, and asset for the vertical reaction. Now click apply. Click apply, and you can click on the point reaction, or you can click on integrative wall reaction. You can click on option, display unit, no, option graphic preference, maximum graphic font size. You can input it 5. Okay, now the font size is click it again, graphic reference. I want to reduce it to 3. Click OK. Yes, it's so for the reaction at the support. This support is you come back to undeformed shape, and you can check it support. If you show at the point reaction, show only for the support. 1, 2, 3. The position is the support position, and this one is not so only for the support. You can see here is the result of the one wall panel. Okay, the total result of one wall panel. You can show the result in more accurate to avoid any error by using a point reaction. Can make you confused about the result. You can show about integrity for result. It's only one at the center of the wall. It's the result of the vertical force. If you want to display other force, you can tick it all for the moment and horizontal force reaction. This one is difficult to check. You can show it one by one. If you want to check about the moment. Okay. And other option, you can display the whole result of the left core wall and right core wall as a peer result. Click on the display, say stresses forces. Click on load case or load combination you want to display. Now let's check about the load combination, and click the component S11 or S22. For the F11 and S22, you can check about the local axis. Now I click S22 and sorry, not this one. Come back the moment. Okay, the moment, and click on peer. The active the default member force diagram for friends. Only click or tick on friends, so we want to display as the peer force. Click on peers and click on axial force. In the load combination, now we want to display for the ultimate gravity load. Click apply. Yes, this is the total. Okay, the total value of the axial force for the right core wall, and add this value for the left core wall. It is easy to understand and to check when you use the total of the one core wall. Yes, you can show for the moment 33. Now you see here the direction of moment M33 is moment in this direction, and moment M22 moment in this direction. You can change load combination by clicking. Now I want to check in the combination is combination positive. Now let's click for the M22 and M33. Yes, M22, the maximum when you apply the wind load in y direction. The total at the base of the core wall is 41,114 kilonewton meter, and you can click other direction M33. Is 703 kilonewton meter. For this load combination, the control load combination, you can change for the MH in M33. Now the maximum value is 47,038 kilonewton meter. You can check in different load combination and direction, or you can create the load envelope. It is easy to check for the maximum and minimum result force. In this one, I not yet create the envelope, so in actually you have to create envelope force. Now I want to show you what is different when you show the actual show the force at the joint, at the support, and show the force at the pier. It is easy to understand and check the force on the whole core wall at the right side and at the left side. Now let's continue to design. To design core wall or wall in ETABS, you have to assign the pier. Okay, you can check here, assign pier level, or you can click on design, shear wall design, and assign pier section. To assign pier section, now click on undeform shape. Click on select, or you can click select in the graphic by use this select option, or you can click on select object type, click on walls, click select, click close, shift middle mouse, rotate, click on design, shear wall, assign pier section. You can assign pier section, but before assign pier section, you have to assign pier. This one, assign pier level. Okay, assign pier level. In the default, there are 3 pier level: P1, P2, and P3. And you can check which one is P1, P2, and P3. You can assign it differently. Indicate you can assign at the right core wall as the P1, or and the left core wall as P2. Now let me check it again. It is assigned or not? Yes, P3. The tab automatically assigned when you use the option core wall default in this software. P3. Okay, P3. So this core wall automatically assigned as the P3. Level name. This one is P2. Okay. It indicates the software automatically assign. You do not need to assign it anymore. If this software not assigned, you have to assign it manually. I show you. You can click on wall panel you want to assign it. Okay, in the case you want to assign it the whole wall panel, you can click on the select object type, click on walls, select, and after that click on assign pier level, because this pier level automatically generate and assign in into the structural wall. So in the case we do not want to create and assign it anymore. If you open assign and do not yet generate P1, P2, and P3, you can click on modify show and add new name, and you can change name or delete after you create and create for PS label. You can assign it. Okay, click on apply. Okay, now escape, and after escape again you can click on previous select and design, shear wall design, assign peer section. To assign peer section there are three options. You can use CNT or uniform reinforcing or general reinforcing. It is a easy method. We use a uniform reinforcing. Okay, now you can change the material. In the case we select for the all or the wall, I use the same material. Now click the C45 megapascal cylinder. In construction site, you have to you can choose it from floor to floor, so the strength you can assign it differently from every 4 floor or 3 floor. You can choose it. Now in this tutorial I want to use the same concrete property from the bottom to the top of the core wall. And distributed bar, the bar size we use now let you 16 and the spacing 150 millimeter, and the clear cover is 25. It's okay. And at the end bar at the corner we want to use 20 millimeter. And reinforcement you can use option to be designed or to be checked. Now in the case I want to use to be checked. It is easy. You want to check D and C ratio. Click OK. Come back, design, wall, shear wall design. You can change the design code. If you want to change it, you can change to the what code you want to design. If you want to design to SI code, you have to check about apply load. You apply in the according to the SI code or not. If you want to change to BS code, so you have to check about the wind load. The wind load of BS code is not the same with the zero code. You have to change it. The magnitude or load applied for the wind force is different from the zero code, but for the gravity load and the load applied on the floor, it is similarly. And material response care, okay. Material, now you can change it. Material, and for the shear you it the same, okay. And the country you can change it to specific country, UK, nationality, local nation. You keep your default, and you can use a nominal curvature or nominal stiffness. Okay, click OK. Okay, now you can click on come back, check it again, and you can check about the section, wall section, modify. Yes, it's correct now. So after that you can click on design again, click on shear wall design, and select load combination you want to design. In the case you have to include for the lateral force and for the gravity lateral load and gravity load, and C select, click import to design combination, click OK. If you do not import the load from the left to the right panel, the ETABS will be create another new load combination. We don't want to create other new load combination. So click on wall design, start design and check. Okay. Pier longitudinal reinforcing area, millimeter, square millimeter, and you can check about the total revalue in pier. Now in the case we click on design again, click on the shear wall design, click on this design display info, click on pier DC ratio. We want to check about the design and capacity ratio. Click apply. So you can check the ratio is only 0.2%. It lower than 1 is okay. It is design value or the DNC is over 1, so you have to increase the reinforcement discrete reinforcement spacing and increase the reinforcement diameter or increase the thickness of wall. So in the case the right core wall and the left core wall is acceptable. The design ratio is only 27%. This one is around 27 and 28%. Okay, it's acceptable. Come back, click on design again, shear wall display design again. Now we want to check about reinforcement ratio. Okay, pier reinforcing ratio. Okay, click on apply. What is the ratio? Now again, NA. What it mean NA? Design, shear wall design again. Select object type, walls designed, shear wall designed, display info, pier reinforcing ratio, do not show the value. Shear for the shear reinforcing, in the case all the pier reinforcement ratio is not so, you can check it manually by the total area of reinforcement over the total area of the cross-section area of the pier, and so you can check about the reinforcement ratio. Now pier DC ratio is lower than 1. Okay, now we complete the tutorial. In the tutorial you can use the analysis and design result for the ultimate, for the strength design, and for the service we will come back and modify the thickness again. We check about the natural frequency, we check about the overall tree again. Thank you for your watching. Thank you. I hope you enjoy this tutorial. For more info, you can ask me below the comment in my channel. I will reply you about what you want to know. After we complete analysis and design, you can check about the result. Click on one element, right click. This one you can check about the design result. Increase the zoom 150%. You can check about this wall panel. SCK is correct. Yes, you have to verify about the material strength of material, about the concrete and rebar. Yes, rebar is correct. And for the shear and for the main rebar, we use the same. We use the same strength, is 400 megapascal. And for the concrete, okay, it's correct. Length and thickness, yeah, correct. Height and alpha cc for the UK national net is 0.85. For the default national net is 1. Alpha LCC is also 1 for the default national net. Gamma S certificator of rebar is 1.15. Gamma C for ultimate for the certificator of concrete is 1.5. And the station check top and bottom ID leg 1, leg 1, leg 2, leg 3, different leg, left side, right side. In the structural design, the load control load combination. The control load design is wind in y direction, minus direction. Okay, for the panel. And the station top and bottom, the design DC ratio is 0.25. is 25%. Is acceptable. Is less than 1. This is the total of the NM applied in this 4 panel. You can check more about the apply load and see design. This is the VOC C design resistance of concrete, and this one is the apply VAD. VAD is 243. Is less than the resistance of concrete. Is okay in this case. And VOD, the design resistance, is 443. It's okay. Is greater than the apply V, the normal and the shear. This one, the kilonewton, is the shear force. This one the shear resistance. And this one is NED and apply and ultimate. Yes, click close. Thank you for your watching. I hope you enjoyed this tutorial. It is how you can analyze and design core wall in ETABS. For the strength design, you can use this result. The modified thickness, we keep it 0.7 for the column and 0.35 for the core wall, or you can increase the core wall to 0.7 at the same column to design the reinforcement. But for the visibility, we have to come back and verify the thickness again, E, and we come back to check the overall tree, inter-story tree, and natural frequency to check it again in the circuit limit state. For the ultimate limit state, we can keep to use the result. Okay, thank you for your watching.